this is our final episode in our 3-a-day multiple choice marathon. Congrats to those of you who have made it this far. I really hope that this was truly beneficial for you and that you also shared with someone. If you didn't, it's always never too late to share. All right. So go ahead and share the link to the videos. All right. Or just share the link to the channel. Tell a friend to tell a friend that we have been doing not just paper two questions on Saturday Night Live at 7, but we are also working CSEC multiple choice past paper questions. And today we're doing the 3 last questions of the May 2019 paper. So here it goes. Yeah, also if you're new here, let me know. All right, question 58 says we have these two triangles and we see the lines OAA prime, OCC prime, and OBB prime. All right, so let me just ensure that you can see what we're referring to. So we have this line OAA prime, OBB prime, and I'm going to put in red since it's also on the same line, OCC prime. All right, all of those are straight lines, and we have the triangle ABC, which is mapped onto the triangle A prime, B prime, C prime by an enlargement, and this is our center of enlargement right there. So, all right, what is the scale factor of enlargement? When we are asked to find the scale factor, we are being asked to tell what can I multiply? Let me say it like this. What can I multiply the length of this line by, OA, to get to OA prime? We could ask it based on another point. What could I multiply the length of this line, OC, by to get to actually OC prime? All right, so which means simply, I mean, if I ask you what can I multiply 2 by to get 6, you're going to tell me 3. How will you find your answer? You're going to simply say 6 divided by 2, and you get the answer 3. On that basis, with that said, we are just going to look at the fact that, all right, the entire distance from O to A prime is going to be 1, 2, 3, 4 units. All right, 4 square units. So that's going to be OA prime is going to be 4 units. And OA is actually going to be 2 units. And based on what we just said, we can divide these two lengths to find the scale factor of enlargement. So we take the length from the center of enlargement to A prime and divide that by the length from the center of enlargement to A. We could have also used OB prime and divide that by OB, or OC prime and divide that by OC. All right, any of these could have given us our answer. All right, so 4 divided by 2 would actually give us 2. That is your scale factor of enlargement, which is C. If we looked at OB prime, we would have gotten 1, 2, 3, 4, 5, 6 units divided by the original point, the length to the original point, which is 1, 2, 3 units. All right, and you would have gotten 2. If you tried it with OC prime divided by OC, you would have still gotten the correct answer. All right, so we can now move to question number 59, or penultimate question. A plane is flying in a direction of 45 degrees. So we know we're talking bearings, which means we need to, get diagrammy. All right, so we are thinking about the plane leaving, let's say, from this point. And so it means that we need to identify where exactly north is from that point. We're going to draw our north line. All right, so it says the plane is flying in a direction of 45 degrees. So we know that we are going to leave from here and we're going clockwise. 45 degrees. Now, if 90 is just about here, I'm going to draw that in red. All right. Then we know 45 is halfway there, which is going to be there. And you can label your bearing. All right. Well, even if not with the 3 digits, you can still label your angle to say that this is 45 degrees. All right. So here we go. That's 45 degrees. Now, what the plane does is change its course and it continues in a clockwise direction to, well, it goes now in a clockwise direction to 135 degrees. Now, where would a bearing of 135 degrees fall? That, of course, would have been 90 plus some more degrees. So if we're going to take our bearing from here, or north line again, and we go right around to 90, we need some more to get to 135, which is just about 45 degrees. So we need that. All of that, that entire bearing um, would have formed our angle 135 degrees, which is the direction to which the plane is not, the plane now, I got that direction there. All right, so it says the angle through which the plane turns is gonna be, and that's gonna be from, let me just get a different ink. The plane was on this bearing first, and then it ends up at 135 degrees, which means the angle through which the plane would have turned would be 135 minus 45. That is not a 5. All right, which would give us 90 degrees. And of course, you would have seen that this is 45 and this is 45. So that would have been 90 degrees. And that's it. Our answer is B. Now to our final question. All right. And you can say bingo. If you reach us, you reach far. All right. If you've been through all 60 questions with me, let me know in the comments so I can big you up. All right. So here we go. This one says we have, you see the diagram. All right. The angle of depression of a point X from Z, coming from Z, the angle of depression is 30 degrees, right? So, all right. And it also says X is 10 meters from Y, as you can see. All right, 10 meters from Y. The height of YZ is the height YZ is what we're being asked to find. All right, so we need to find this. All right, based on something we would have discussed in a previous episode about alternate angles, we know that this angle here, 30 degrees, is also equal to this angle here. So we know to write us at 30 degrees. All right, so we are definitely going to be using a trigonometric ratio. We have a right angle triangle formed here. We know an angle inside it. Well, we know two angles. Well, we know all the angles. But anyways, all right, so this angle here is 30 degrees. We have the side that's adjacent to it, which is 10 meters. And we want the side, so adjacent, and we want the side that's opposite to it. All right, now we are going to look for the trigonometric ratio that involves the adjacent side and the opposite side. And I'm guessing you would have been familiar with this nice way of remembering. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent is opposite over adjacent. So kato. But anyway, moving on. All right, so we have the ratio that involves the adjacent and opposite is going to be tangent. So we know tan of whatever angle we have is going to be equal to the opposite over the adjacent. All right, so that means that tan 30 degrees is equal to opposite, which is YZ, which is what we don't know, over the adjacent, which is 10. Already, you notice tan not even in none of your other answer them except A. So it's highly likely that that is your answer. So from early, you can start eliminate stuff. But anyway, let's just finish the question for finishing its sake. We want yz, which means we are solving this equation to make yz left on the right-hand side by itself. So we go times 10, times 10, and now we have 10 tan 30 being equal to yz. And let's not forget our degrees. All right, so our answer would have been A. And we're at the end. I'm Miss Gordon, and I will see you tomorrow night at 7 p.m.